Hello. In this video, we are going to go over how to find the area of a triangle given these 3 points. What we're going to do first is we're going to find the vectors of AB and then AC. We're going to find the cross product of those vectors. And when we do that, we're going to use a matrix method this time. We're going to find the determinant of a matrix by using the minors of the bigger matrix. And then lastly, once we get that final vector, we're going to take that magnitude and that's going to, and then multiply that by 1/2, and that's going to be the area of the triangle. All right, so let's just jump straight into it, shall we? So first, what we need to find is AB, vector AB. In order to do that, all we need to do is take the points that correspond to one another. Like this is going to be x1, this is going to be x2, this is going to be y1, y2, z1, z2. Beautiful. So we're just going to take x2 minus x1, y2 minus y1, and then we're going to have z2 minus z1. Cool. This is going to create us our vector. So nice and easy. Let's get rid of this guy really fast and make sure we put in our proper form in component form. Beautiful. So we see that this is going to be -4, -8, 0. That is going to be the vector for AB. Now we're going to find AC. So AC, we're going to do the same exact method. We're going to go x1 minus x2 minus x1, y2 minus y1, make that a little cleaner, and z2 minus z1. Perfect. We do some math, solve that out, and we get -2, -4, 4 as my vector for AC. All right, perfect. That is the beginning part of that. Next, what we need to do is find the cross product of AB and AC. In order to find this cross product, what we're going to do is use a matrix method. And we're going to find the determinant of that matrix. So I'm going to write out I, J, K, and then I'm going to write the i's underneath it, the x's, -4, -2, -8 for the j's, -4, 0, and 4. And just so you see that a little better, I'll write the vector of AB right here, -4, -8, 0, and AC right here as -2, -4, 4. So I just replace them under that line. And then here, since we have a 3x3 matrix, we're going to do this by minors. And what that means is first we choose our I. So we get our I, and then the I row gets canceled out. And the only thing that's left for a mini matrix or a minor matrix would be -8, -4, 0, 4. Just this inside. So let's make a little tiny one for us to just manipulate with as we go. So we have this matrix. We're going to start with our first minor matrix, and we're going to take our I, cancel these ones. We get, we'll replace this one with blue. We get I times the matrix of -8, -4, 0, 4. We're going to always go minus on that second option, minus J. And then for J, what we're going to do is come back down here. We'll do it in orange. I, J, K. I'm just going to rewrite it so it makes a little more sense. -8, -4, 0, 4. We're using J this time, so I can't use the rest of those, and I can't use the row, the column that J is in. So what is left, you see, is -4, -2, 0, 4. And I just keep it exactly the way it looks. And I'll go, all right, well, -4 is now my first one. 0 is the second in the first row. The bottom row is going to be -2, 4. And we're going to do that one more time. We'll go I, J, K, -4, -2, -8, -4, 0, 4. You don't have to write it out 3 times. I'm only doing that to show you the visual representation of it. And then this one's going to be a plus because the signs alternate. It's very important that we alternate those signs. and we write out our remaining matrix, -4, -8, -2, -4. All right, so now we have our minors set up to find the determinant. To define the determinant of a 2x2, which is pretty straightforward, we'll write the directions over here. We have A, B, C, D, and all we have to do is do A times D minus B times C to find the determinant. So that's what we're going to do. Oops, I moved everything over a little. So that's all we're going to do. We're just going to start applying that now. So I'm going to have I times -8 times 4 minus -4 times 0. We'll have minus, and let's move this over a tad. We'll have minus j times -4 times 4 minus -2 times 0. And then we'll have the last one plus k. Let's squeeze this one in here as well. And we can move that over. Move these guys over a little bit as well, just so it's just a little cleaner. Perfect. All right, then we'll add our k. And we'll do -4 times -4 minus -8 times -2. So we're going to move that over a tad so we can see all of that. All right, cool. Let's clean that up. So again, times -2, -8. And now we're going to clean everything up. I is times -32 minus 0 minus j is -16 minus 0 plus k, which is going to be 16 minus 16. Clean up some more, -32j plus 16, sorry, -32i plus 16j plus 0k. Now that is that vector. What we need to do now, that's the cross product vector. So now what we need to do is take the magnitude. We're going to square root -32 squared plus 16 squared plus 0 squared. We're going to grab a calculator. You're going to type that in there, and you're going to get square root of 1280, and the square root of 1280 can be simplified, I believe. So 1280 can be simplified to 16 times 16. 1280 divided by 256 is 5. So we can do 16 square root 5 is the square root of 1280. And then the last thing you need to do is, since this is a triangle, we need to multiply that by 1/2. And our area of our triangle, given those 3 points, is 8 square root of 5. Let me write that a little cleaner. 8 square root of 5. That's it.